Hello guys, welcome back to new video. In today's video, I'll solve Rohan's law for matrix. Now let's solve this problem. In problem statement, you can see in this problem statement, we need to find to calculate a to the power n and return the a10 element of mod this value. Okay, mod this value. Now go to 110. Now let's like example. Suppose this value, okay, this value will be 1110. Okay, this matrix. In this matrix we need to find a to the power n, value. We need to find this and its position this. We need to find this position, mainly this position. Okay, now how can we find this position? If we multiply this a itself n number of times, we multiply this. And how can, if you know matrix, if suppose a matrix a square, okay, how can we write this? We will write a into a, and in matrix it will show just like first 1 1 1 0, and second 1 1 1 1 0, second one. And if we multiply and add this, what will show? It will show just if we first this one multiply to this one, and this one, it will be addition. Okay, this one multiply with this one, and plus this one multiply with this one, and 1 plus 1, it will be value 2. And next, if we multiply this one, and this one, this 0 1, multiply, then it will show 1. Okay, next following it will show the 1 and 1, suppose accordingly like this. Now what is the time complexity of this? Time complexity will be O of n, and space complexity will be O of 1. Put first we need to just def multiply matrices themselves a, b, and 1. Then result equals to first 0, 0, and second one will be 0, 0. Okay, now go to lesson. Take for loop for I in range. For I in range will be 2, and another for j in range. J in range, it will be also 2 value. And for k, we will create another loop for k in range 2. Okay. Now condition the result I and j is equals to a I and ai and ak. Then it will multiply with b k and b j. We can b j, and it will be 1. First then it will not. Next line, result I j modulo equals to 1. Then it will return result Now for def power matrix function, def power matrix function cell a mod in mod, and middle function if n equals to 1, then return a, okay, or if n modulo 2 equals to 0, then half power cell dot power matrix, cell power matrix a 1 n and then 2 mod. Then move to next line, and it will return self dot multiply matrices and half power times upward and mod. Return multiply matrices upper mod, then go to next line, or else it will be returned from function of half power and equals to self power matrices, a comma n into mod. Then return self multiply matrix, self power matrices a comma b self multiply matrices, return self multiply self and half, also half power mod, then first in serial, then the mod value, okay, mod value, and value will be this mentioned mod 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 and matrix a equals to 1 comma 1, then 1 comma 1 0 0 and then result matrix self dot power matrix a and mod value. Then it will return result matrix 1 and 0. Okay. Now submit. Solve this problem.